going to walk through the problems from the power, product, quotient, and chain rule with trig functions homework. So this first one here that we're looking at is finding the derivative of y equals the sine of 8x. So because we have a function, 8x, that is composed within a secondary function, sine, we're going to rewrite this as y equals the sine of u, where u is equal to 8x. And now we can find the derivative of y with respect to x using the chain rule. And the form that we found for the chain rule was dy dx is equal to dy du times du dx. So this is what we're going to be using for the majority of these. Sometimes we'll use it multiple times. But first we have to find dy du. Well, that'd be the derivative of y with respect to u. So dy du is just the derivative of sine u, which is cosine u. And then we'll find du dx. Well, du dx is the derivative of u equals 8x, which is just 8. So if I multiply those two things together, I get 8 cosine u, which is equal to 8 cosine 8x. And you need to always remember that you need to put it back in terms of your original variable. So our final result here is 8 cosine 8x using the chain rule. For our second problem here, we've got the sine of x over x cubed. So this one is just going to be a quotient rule problem because we're looking at u over v. So we'll do the quotient rule, which is v du minus u dv all over v squared. So that starts out as x cubed. That's our v. And then du, which would be the derivative of sine. Well, the derivative of sine is cosine. So v du minus u, and u is just sine x. And then dv, which will be the derivative of x cubed, which would be 3x squared. We'll divide that all by x cubed squared. Right? X cubed squared using exponent rule should just be x to the 6th. So that'll be x to the 6th. And we'll do just a quick simplification since we have an x cubed and an x squared and an x to the 6th that they're being divided by. We can at least divide them all by x to the 2nd power. So that'll leave us with x cosine x minus 3 sine x. And since we divide them both by x squared, we'll drop that power from x to the 6th to x to the 4th. So our final result is x cosine x minus 3 sine x over x to the 4th. For our next one here, we have y equals cosine to the 4th power of x. And remember, that's just the same thing as cosine x being raised to the power of 4. So we should see that this is a function being composed within another function. This is y equals u to the 4th, where u is cosine x. So we'll first find dy du. dy du is going to be the derivative of u to the 4th, which is 4u cubed, and du dx, which will be the derivative of cosine, which is negative sine x. When I multiply these two things together, we're going to have a negative 4. And remembering that the chain rule says dy dx is equal to dy du times du dx. So we'll have the negative 4. And then we'll have the u cubed. Well, u was cosine x, so instead of writing u cubed, we'll write cosine cubed x. And we still have our sine x. So our result here is going to be negative 4 cosine cubed x sine x using the chain rule. Right? For our next one here, we have 3 secant 1/2 x. And so since it's not just 3 secant x, but it's 3 secant of a function, we'll treat this as a chain rule problem. 3 secant u, where u is equal to 1/2 x. And we'll just find dy du, which will be 3 secant u tangent u, because the derivative of secant is secant times tangent. And then du dx, which is just 1/2. And of course, remembering our chain rule that dy dx is equal to dy du times du dx, we'll just put all of this together. The 3 times the 1/2 is going to give us 3 halves. So dy dx is 3 halves. Secant u, well, u is 1/2 x, so secant 1/2 x. And then tangent u, so tangent 1/2 x. And that will be our final result. 3 halves, secant 1/2 x, tangent 1/2 x. For our next one here, we're looking at a product of two functions, cotangent x times the sine of 2x. So we've got a couple of different ways that we could look at this one. One is just to go and use the product rule right off the bat. And so if we use the product rule right off the bat, we've got u times v here. So we'll use u times the derivative of v plus v times the derivative of u. U is cotangent x, so we'll have, all right, y prime here. Y prime is cotangent x times the derivative of sine of 2x. Well, if I have sine of 2x, that's like a chain rule problem. Right? That's the sine of, since we've already used u, we'll use a different variable here to think about it. We'll call it the sine of w, where w is equal to 2x. Well, the derivative of sine of w would be cosine of w, and the derivative of w would be 2. So we're going to end up with 2 cosine w, or 2 cosine 2x. Then we'll add to that v du. V is sine 2x, so we just have a sine 2x there. And then du is the derivative of cotangent, and the derivative of cotangent is negative cosecant squared. So we'll multiply that by negative cosecant squared of x. So we can just rewrite this out as 2 cotangent x cosine 2x minus sine 2x cosecant squared x. And that answer would be acceptable. You could use the double angle on sine 2x if you wanted to turn that into 2 sine x cosine x. And then you could do a little bit of cancellation, but it's not really going to get much simpler. The other option that we have here is, as I was just saying, there is the double angle identity for sine. So I could, we'll come down here and do this in a different color. I could rewrite this as cotangent x is cosine x over sine x. And the double angle identity for sine 2x is 2 sine x cosine x. And if I do that, I can just immediately cancel out the sine x over the sine x, which just turns this into 2 cosine squared x. And the derivative of 2 cosine squared x, so let's rewrite this. This is y equals 2 cosine squared x. And that's just like having y is equal to 2 u squared, where u is cosine x. And so then we'll use the chain rule on that. And so the derivative of y, or the derivative of 2u squared, ought to just be 4u. So dy du is 4u, and du dx is negative sine x, the derivative of cosine. So we just end up with negative 4 u, which is cosine x, and sine x. So negative 4 sine x cosine x. Let's see if we'll run out of room and it won't let me write it there. So just move that over a little bit. And negative 4 sine x cosine x. And that can be rewritten using double angle identity also, but we won't bother. And we could probably simplify that to cotangent x cosine 2x minus sine 2x cosecant squared x that we got the other way down quite a bit. But I'd be fine with either of these answers. And they're both equivalent to each other. Okay, for our next one here, we've got 2x cubed cosecant x. So this is just going to be a product rule problem. We have u times v. There's no composition of functions here. So it'll just be the first function, y prime, is the first function, times the derivative of the second function. Well, the derivative of cosecant is just negative cosecant x cotangent x. And then we'll add to that the second function, cosecant x, times the derivative of the first function, which using the power rule is just 6x squared. And we might as well, it's not really necessary, but I'm going to factor out the 2x squared cosecant x from both of these terms. So if I factor out a 2x squared from here, I've still got the x, and I've still got from here, and I've still got a negative sign, and I've still got a cotangent x. And over here, if I take out a 2x squared cosecant x, all I have left is positive 3. So I'm going to rewrite that first. So it's 3 minus, and we said we had a minus x cotangent x left over here. So looks like that's a good final answer for us. For number 7, we've got y equals the square root of sine x. Well, that's just a composition of functions. It's the square root of u, where u is equal to sine x. So we'll use the chain rule. The derivative of the square root of u is 1 over 2 root u, and the derivative of sine x is cosine x. So this just becomes 1 over 2 root u, so root sine x. And then we'll multiply that by cosine x, which is just effectively going to put a cosine x into our numerator. And so there's dy dx using the chain rule. And you really want to get to the point where you can start doing these ones in your head. It's just going to make your life a lot easier down the road. All right, for our next one here, once again, we've got y equals a function composed into another. So in this case, it's u to the 7th power, where u is equal to 3x squared minus 5x plus 1. So we'll take our derivative, dy du is equal to 7u to the 6th, and du dx is going to be equal to 6x minus 5, both of those just using the power rule. And so our final answer, dy dx, should just be the product of those two. 7 times u, which is 3x squared minus 5x plus 1 to the power of 6, times du dx, 6x minus 5. For this next one, we've got tangent 2x over 2x. And one of the most common things I see happening here is people say this equals 1, and then dy dx is 0. Well, no, that's not true. Tangent of 2x over 2x is not equal to 1. The limit as x approaches 0 of that is equal to 1, but that doesn't just mean that the function itself is always equal to 1. So to take the derivative here, we're going to have to use the quotient rule because we have a quotient of two functions. So we'll start off with our denominator, 2x, times the derivative of our numerator. And then to find the derivative of tangent 2x, right, we have to treat that like it's tangent of some function. We'll say w, where w is equal to 2x. So the derivative of tangent w with respect to w would be secant squared w, and the derivative of w with respect to x would just be 2. So the the du part of our quotient rule, right, is going to be 2 secant squared w, or 2 secant squared 2x. So there's our v and then our du. So v du minus u, that's our tangent 2x, times the derivative of v, well that's just 2, so I'll throw that out in front, minus 2 tangent 2x. And of course it's all over 2x squared. And make sure you get the parentheses around there because there's a difference between 2x squared and 2x squared. Those do not equal each other. Okay. So we'll just do a small bit of simplification here. This is 4x secant squared 2x minus 2 tangent 2x all over 4x squared. And then we would note that they're all divisible by 2. So we'll just divide everything by 2 and get a final answer of 2x secant squared 2x minus tangent 2x all over 2x squared. And that should be our final answer. All right, for our next one here, cosine to the 4th of x squared. Well, this time we do have a function being composed into another function. So this is y equals u to the 4th, where u is equal to the cosine of x squared. But then we'll probably note that u equals cosine of x squared is a composition of two functions again. So we're going to have to rewrite this as u is equal to the cosine of v, where v is equal to x squared. So in order to find this derivative, we're going to have to do 3 different derivatives. The derivative of y with respect to u is going to be 4u cubed using the power rule. But to find du dx, we're going to have to use the chain rule, which says we're going to have to do du dv times dv dx. So we originally wanted dy du times du dx. So really what we now need is dy du times du dv times dv dx. So du dv is negative sine v, and dv dx is 2x using the power rule. So for this one, we'll now multiply all those things together, and as we do that, we can replace the u's and the v's with what u and v are equal to. So our final answer, well, our unsimplified, we'll see if we have to simplify, answer dy dx should be dy du, which is 4u cubed. So that will be 4, and then u was cosine of x squared, so that'll be cosine cubed of x squared. So that's our dy du. And then we're going to multiply that by du dx, which is du dv times dv dx. So that'll be a negative. I'll put the negative out in front. Sine of v. Well, v was x squared. So sine of x squared. And then times the derivative of v with respect to x, which was 2x. So this would be fine, but it's probably nicer to write it out as negative 8x cosine cubed x squared times the sine of x squared, and just moving that 2x out to the front. So there's our final answer. For number 11 here, we've got a product of two functions. That's the first thing we should notice, that we're going to have to use the product rule. This is u times v. So our derivative should be u, which will be 3x squared, times the derivative of v. Well, if v is sine of 4x, that's like the sine of w, where w is equal to 4x. So that derivative should be cosine w times 4. So that'd be 4 cosine w, or 4 cosine 4x. So that's our u dv, plus, now we'll have v times du. That'll be the sine of 4x, that's our v, and the derivative of u will just be 6x. So as we put this all together, we end up with 12x squared cosine 4x plus 6x sine 4x. If you want to factor a 6x out of both terms, go right ahead, but it's not really necessary. All right. For our next one, we have the square root of x squared minus 1 times sine of x. So again, we should note that this is u times v. So we're going to use the product rule. So we'll start with y prime is equal to u square root x squared minus 1 times the derivative of v. The derivative of sine of x is just cosine x. So there's u times dv plus v, that'd be sine x, times the derivative of u. Well, the derivative of u, right, u is equal to the square root of x squared minus 1. Well, that's a function within a function, so we'll call that the square root of w, with w equal to x squared minus 1. And to find that derivative, that should be 1 over 2 root w, either using the power rule or just because we memorized the result from the power rule. And our derivative here should be 2x. So to find the derivative of root x squared minus 1 to put into our product rule, we should have those two things multiplied together. So 2x over 2 root x squared minus 1. We'll see that the 2's cancel, so that just gives us x over root x squared minus 1. And I'll just put the x there, and the root x squared minus 1 there. And since I don't really care about radicals and denominators, I don't really need you to do anything else with that. That's a perfectly good answer. So just 3 more here to go. We've got sine of 5x times the cosine of 6x. So once again, we've got a product rule, u times v. So our derivative, right here, y prime, should be u, sine of 5x, times the derivative of cosine of 6x. Well, that's the cosine of w, where w is 6x. So the derivative should be negative sine of w times 6. So we'll have times negative 6 sine of w. And then we'll add to that, that was u dv, so we'll add to that v, cosine of 6x, times the derivative of u. Well, to do the derivative of u, that's going to be u is equal to sine, let's see, we've used u, we've used v, we've used w. We'll just say sine of a, where a is equal to 5x. So our derivative should be cosine of a times 5, right? Because that's the derivative of sine of a times the derivative of 5x. So 5 cosine a, or just 5 cosine 5x. And it's nice to have all the coefficients and stuff out in front. And we get negative 6 sine 5x sine 6x plus 5 cosine 6x cosine 5x. And oftentimes, and not sure if I did this in my answer key, but oftentimes I'll put that term that's positive in front of the term that's negative, so I might have just flopped these two around. So I might have written 5 cosine 6x cosine 5x minus 6 sine 5x sine 6x, and maybe flip these around or flip these around, doesn't really matter. Any of those are equivalent to each other and would be perfectly acceptable answers. All right, we forgot 2 more to go. So this one here is a quotient rule problem, u over v. So we'll start with v times the derivative of u. Well, if u is sine 2x, then we could call that the sine of w, where w is 2x, and to find that derivative, we would do cosine w times 2. So du will be 2 cosine w, or 2 cosine 2x. So there's our v du, minus our u sine 2x, times our derivative of v. Well, our derivative of v is cosine 3x. So that's the same as cosine. We'll use a again like we did in the last problem, since we've already used u, v, and w. So with a equal to 3x, so the derivative should be negative sine of a times 3. So now we'll have negative 3 sine a, where a was 3x. So there's v du minus u dv, all over our denominator, cosine squared of 3x. And we'll just rewrite a little bit. We've got 2 cosine 2x cosine 3x as our first term in the numerator, and then we have a minus and a minus there, so that'll be like a plus. So we'll have a plus 3 sine 2x sine 3x, and it's all over cosine squared of 3x. And here's our last one for this homework assignment. What we'll first note is that this is a function composed within another function. So this is y equals u cubed, where u is equal to x squared tangent 2x. So to start off with, we know we need dy du times du dx. So dy du should be pretty straightforward. Dy du is just 3u squared. But to find du dx, well, du dx is going to require us to use the product rule, right? So du dx should be the first function in there, x squared, times the derivative of the second function, so times the derivative of tangent 2x. Well, to find the derivative of tangent 2x, we'll treat that like tangent v, where v is 2x. So our derivative should be secant squared v times 2. So we have u dv, so that'd be u times our 2 secant squared 2x, and then plus our v, which is tangent 2x, times the derivative of our x squared, which is 2x. So there is our du dx. So now we can just take our dy du and we can multiply it by our du dx. So dy dx here is going to equal, and I'm going to notice over here I've got a 2x squared and a 2x here, so I'm going to factor, before I write this all, I'm going to write 2x times x secant squared 2x plus tangent 2x, just to simplify this down a little bit more nicely. So when I multiply the 3 by the 2x, I'm going to get 6x. So I'm going to have 6x, and then I'm going to have u squared, where u was x squared tangent 2x. So there's my u squared, and what's left is x secant squared 2x plus tangent 2x. And that is our final derivative. So that's all the problems. There are 15 problems there from our power product quotient chain rule with trig functions homework walkthrough.